Whether you're a religious person or a believer in science, you have to have faith. When it comes to religion, the faith is quite obvious. You believe in God, a deity, or some sort of presence that is responsible for everything in the universe. But what about a scientist or a person who believes in science? Where does his or her faith come from? And today we're going to be talking about just that. Welcome to What the Math. So what is this thing that I'm talking about that requires faith? For a scientist, it is of course the dark matter. The invisible, the undetectable material that seems to hold our universe and our galaxies together. It has never been detected, it has never been found, it is very theoretical, but without it, universe and galaxies and everything else in them do not make sense. Now in Universe Sandbox 2, unfortunately dark matter is very limited, but it is here and we're going to investigate it today. It's actually, there's a button for it, delete all dark matter. And let's actually look at that. So what is dark matter? Well, nobody knows. What does it consist of? Nobody knows. It is very theoretical, and we only have 2 simulations that actually have dark matter, I believe, or possibly 3 simulations. We're going to start with this. This is called Any Galaxy. Let's actually slow this down and look at it from a distance. So this is a central black hole that has no name. And if I zoom out, you'll notice that this is a galaxy filled with these red spots everywhere. What are these red spots? Well, thanks to one of the developers of the game, they actually informed me that this is actually dark matter. All of these red spots are dark matter. So if I accelerate this, you'll see that this galaxy will kind of slowly come together, come into one little galactical piece. And what's holding it together is, of course, dark matter. Now, dark matter was a theoretical concept developed or actually found by the infamous Jan Oort, who's also responsible for the Oort cloud. And he basically said, listen, it doesn't make sense that, you know, the way the stars are spinning around the black hole, they should be flying away faster. There has to be something else holding them. And he said, maybe it's some sort of a dark matter. And then with time, we actually realized that he was right. There's something like 84% or possibly even 85% of all of the matter as dark matter. So in other words, there's only about 15% of actual matter, that's stuff that we can see, the stuff that you're made of, and 85% of the rest is the red circles, red spheres. It's the dark matter that we do not see, do not detect. Okay, well that's interesting. There's also something called dark energy, but that's not something we can explore today. But there's even more of the dark energy stuff that's apparently also causing the universe to behave in certain ways. And so yeah, this is super theoretical, and it's all based on faith. We have never seen it, we have never detected it, we have no idea what it's made out of. The theory says that it's made out of some undetectable, invisible particle that we don't know nothing about. So, you know, when it comes to religion or faith, this is as close as science gets, because if you're a scientist, you have to believe in this, and it is something that basically holds galaxies together. So what I'm going to show you right now, we're going to go back here, and we're going to click on that button. We're going to actually delete all of these red circles and see what happens. So this is the 2 galaxies with dark matter in them, and this is the 2 galaxies without the dark matter. And look at that. They kind of just dissipate. Everything just flies into the universe. There is absolutely no way for these galaxies to exist without this hypothetical, theoretical, unknown, invisible dark matter. So yeah, and this is actually a pretty awesome concept. Now I'm kind of happy that they actually have these 2 simulations in the game. We're going to take a look at the other one in a second, because it does give you an idea what it is and what it does for our galaxy and for basically all of the galaxies and the entire universe. Now without the dark matter, like I said, things will just drift away and will not be held together. So let's take a look at the other simulation. There's another one right here. It's called Database 2 Galaxies. I believe these are the only 2 I found, and there might be more. We're gonna look at this one first. This one starts really slow, and so you already see the dark matter circles right there. And what we know about dark matter is, or what little we know, is that it does seem to come in chunks. It does seem to have these chunky looking locations around our galaxy and around the universe that essentially kind of hold things together. There's very little knowledge we have of it, and most of it is based on observation. So for example, even though it's invisible, or it has to be invisible because that's basically what makes it dark matter, that's why it's called dark matter, we can see its effects in various locations in our galaxy because there's like black spots, and it's not black holes at all. It's actually nothing to do with black holes. So even though it's called dark, it's not really the same concept. But we do get to see a kind of a gravitational lensing from, you know, from basically the fact that it does bend light a little bit, because it is sort of, it does have mass. And so I'm trying to accelerate this just to see what happens to this galaxy when we accelerate time. So it looks like it's going to be coming together into one little piece. And there's actually another galaxy here in the distance that also has dark matter, and it already looks more galactic, looks more like an actual spiral. This one I think will probably become some sort of a sphere galaxy, but let's see what happens to it. And you can see the dark matter is actually orbiting the black hole as well. So it's going to slowly come into one piece. Now, what is dark matter made from? Well, it's a very hypothetical particle. We know there are 17 particles that we are aware of, and this is what the actual matter is made from. And there has to be at least one more particle that we know nothing about, and we think that's what the dark matter is made from. You can, I guess, call it some sort of a darkton or darkon. But you know, there's always theories that try to contradict every other theory. So there's quite a lot of other theories that try to prove that maybe there is no dark matter, maybe there is some sort of other way or other reason why galaxies stay together, why stars orbit in a certain way. But unfortunately, those other theories do not really explain the properties of galaxies and galactic clusters, because without dark matter, all of the galactic clusters would just fly away. There's just not enough matter to hold them together. There has to be something else. But you may also ask, so maybe it's just, you know, maybe our black hole is a lot more massive than we think it is, and maybe that's what's holding them together. And I'm going to show you why that's not true. When what? Well, let's do this. Let's do this first. Let's remove all dark matter, because it seems like there is nothing's happening here. The simulation is not as active as the other one. But let's see what happens if we remove this and accelerate time, and look at that. Everything just kind of flies into the distance, I think. I hope. Here we go. Let's look at this first. You can kind of see it's already dissipating. So this is what happens without the dark matter. Nothing really is held together. Everything just flies into the abyss. So let's go back to the first simulation, or let's actually see if we can find something else. I'm sure they're going to add more later. No, nothing else. But right now, this is what we have. We have only 2 to work with. And we're going to go back to the first simulation. And so here, what I'm going to do now is I'm going to change the mass of both of these black holes to, let's just say, like 100 times more. No, not 100. Let's just say 10 times more. So they're going to be 10 times more massive than they currently are. So this one is going to become 0.3 instead of 0.03. And that one is going to become... let's go back here. Sun. No, not sun. Milky Way. There we go. This one is going to become 0.3 as well from 0.03. But now we're also going to remove all of the dark matter. So this is a little experiment we're doing. So what happens if you have a more massive black hole in the center, 10 times more massive, but no dark matter to do anything else? So what's going to happen now? And go. So this is what happens if you have just a more massive black hole and no dark matter. So it holds everything together at first, but you can kind of see what's happening. So it gets a very, very, very thick cluster in the middle. Everything else kind of slowly drifts apart, and the shape eventually will become more spherical and more concentrated toward the center. But there will be nothing on the outskirts. This part and all of these parts will most likely dissipate and fly away at some point. So let's just wait a few million years and find out what this looks like later. And 700 million years later, these two galaxies came very close. They started interacting with each other, but they're not really interacting in the same way that we see in our telescopes. So instead of really being sucked into each other and, you know, acquiring a part of each other, they seem to have basically destroyed each other. They've flown apart. A lot of the particles, not particles, but a lot of the solar systems here have drifted apart. There's really only the central cluster that we see in both of these galaxies, and they don't look anything like we see in the telescope. So this is not what you usually see. Most of the galaxies look like this. And this is what usually happens when two galaxies interact. So first of all, they do have a very spiral shape. Some of them are more spherical, but nevertheless, they're all as one piece. They don't have any pieces flying really far apart. And in the beginning, this is what happens. Because of the collection of dark matter in here and in there, you'll have one of the pieces getting sucked in this way, and this is actually, there's a word for it. It's called Galactic Tides, and they will then either combine into one giant galaxy, which is what might be happening here, or they'll completely destroy each other, or they might create a lot of really small galaxies. So nevertheless, what is happening here is that it's still sticking together. It's still a big one piece. You can kind of see I think it's now a one large galaxy of 2 times the Milky Way, and it still kind of looks spiralish, more spherical, I guess. But the dark matter that you don't really see here, it's not in the simulation. I mean, it's not simulated in the simulation, but it's still there. It's keeping it all together. Nothing is really flying apart. It's sort of all one chunk. In this simulation, however, if I remove the dark matter again and I increase the mass of the central black hole, it just, after a few million years, it just doesn't look the same. I'm going to accelerate this again. You can see that it just becomes really thick on the inside, not so thick on the outside, and as they approach each other, the interaction is very different. So this is why we think there has to be something, and that something is called dark matter. Whether it's true or not, we don't know. It might actually still be hundreds of years until we find a way to discover this dark matter, because it's just, there's no way to detect it. This is why it's called dark. So there you go, and this is why, as a scientist, you also have to have faith. Without faith, you will not be able to explain a lot of the things that go on in the universe. And I think it takes a lot more faith as a scientist than as a religious person to try to understand and believe in everything that goes on in the universe. So can we believe in this invisible dark matter that seems to hold things together in our universe? Well, we have to, otherwise the universe will make no sense. And so next time you hear someone talk about faith, religion, and so on, you may want to bring up dark matter, because this is the invisible power of the universe that all scientists have to believe in. Anyway, thank you guys so much for watching. Hopefully you enjoyed this video, and hopefully you will like it as well. If you did enjoy this, please leave a comment saying, what do you think? So what is dark matter? Can we actually find it? And if so, how are we going to be able to find it one day? Also, check out some of the other Universe Sandbox 2 videos, and subscribe to this channel if you enjoy space, science, and math videos. Thank you for watching, and game you later, guys. Bye-bye.